last class, we discussed about Dalton's atomic theory. Now coming to the next atomic theory. Even we discussed about the drawbacks of Dalton's atomic model. Because of those drawbacks. Now the next theory that was given by J.J. Thomson, which is known as J.J. Thomson's atomic model. As I told you earlier, all these atomic models like Dalton, J.J. Thomson, Rutherford, we already have in the lower classes. So just briefly we will discuss. Anyway, these models are not included in the present syllabus. Now coming to this, Thomson's atomic model, simply we call it. It is also known as plum pudding model. Okay, J.J. Thomson's atomic model is also known as plum pudding model. Even it is also known as watermelon model. Okay, Thomson's atomic model is also known as plum pudding model or watermelon model. Now, before going to discuss about why it is called as a plum pudding model, why it is called as a watermelon model, first let us discuss about postulates of Thomson's atomic model. What he explained, let us see. In a simple manner, according to him, atom is nothing but a spherical shaped one. As we already know that atoms are spherical in shape. Even Dalton also given that. Now according to him, also the atom is a spherical shaped one. We know atom contains electrons, protons as well as neutrons. But at the time of Thomson, only electrons and protons were discovered. So he explained about the structure of atom in terms of electrons and protons. We know electrons are negatively charged species and protons are positively charged species. According to Thomson, whatever the protons are there, but whatever the positive charge is there, the positive charge is spread throughout the atom like a positive sphere. Okay? All the protons, nothing but the positive charge of the atom is spread throughout the atom in a spherical manner, which is known as positive sphere. Now coming to the position of electrons into this positive charge, the electrons are embedded. Okay? So these are the embedded electrons. Embedded nothing but distributed. Okay? So this is the structure for an atom given by Thomson. Okay? Simply atom is a spherical one and the whole positive charge of the atom is spread throughout the atom and the negatively charged electrons are embedded in the atom. Like watermelon. That is why this is also known as watermelon model. How like a watermelon? We know when we cut that watermelon into half, we will observe that red juicy spot. That this positive charge of the atom is similar to the red colored juicy part of the watermelon. And we know that brown or black colored seeds of the watermelon are spread in the watermelon. In the same way, the electrons of the atom are embedded into the positive charge of the atom. Okay? This way, he explained about structure of atom. Okay? It is simple thing. Now coming to the plum pudding model. So this juicy part is similar to the plum. That is, it is called as plum pudding model or watermelon. Okay? Now coming to the drawback of this model. Now let us see the drawback of Thomson's atomic model. The main drawback of this model is, if you observe the structure, you explain about position of electrons and the protons. But later, after this model, by the time Rutherford did an experiment, about alpha ray scattering experiment of Rutherford, this Thomson's model failed to explain the Rutherford's experiment. Okay, that is the main drawback of Thomson's atomic model. The drawback is he failed to explain Rutherford's experiment. Okay, the Thomson's failure is he failed to explain Rutherford's experiment. Even we will discuss what is Rutherford's experiment. Everything we will discuss. Okay. Note down the drawback of Thomson's model. Now, coming to the next atomic model, even from this experimental you will come to know one of the most important atomic model, that is Rutherford's atomic model. Rutherford's atomic model, a very important model, which is also known as planetary model. Thomson's atomic model is known as watermelon's model or watermelon model. Coming to the Rutherford's atomic model, it is also known as a planetary model. Why it is called as a planetary model, we will discuss further. Before going to discuss about the postulates of this model, first of all, let us discuss about the experiment done by Rutherford. Okay? The experiment done by Rutherford is known as Rutherford's alpha ray scattering experiment. Okay? We don't need to by heart the procedure of experiment. Just simply how we have done the experiment, briefly let us discuss. Before going to discuss about this experiment, we should have clarity about this one, alpha particle. So what is meant by alpha particle? We need to know about that one first. As in the last class once I given what is meant by alpha particle. Everyone remember, alpha particle is nothing but helium plus 2 ion is known as alpha particle. Okay? Helium, we know hydrogen first element, helium second element. So atomic number is 2, mass number is 4. Atomic number 2 means what? It will have 2 electrons and 2 protons. But coming to He plus 2 ion. In the last class we discussed what is meant by ion. Now it is very clear positively charged ion. And plus 2 charge represents means it lost 2 electrons. So its atomic number is 2. It lost 2 electrons. It means alpha particle don't contain any electrons. So it don't contain any negatively charged particles. It contains only positively charged particles. Nothing but protons. As well as in the nucleus, neutrons will be there. But charge of neutrons is neutral. So no need of neutrons regarding the charge. So one important point about this alpha particle we need to know, that is alpha particles are positively charged. Okay? Alpha particles are positively charged particles. Okay? So this is the minimum information we need to know about alpha particle. The alpha particle means helium plus 2 ion. It don't have any electrons, no negative charge. The alpha particles are purely positively charged particles. Okay? Now, coming to the experiment, this Rutherford is taken a source of alpha particles. So this is the source of alpha particles in the form of ray. So this is source of alpha rays. And here somewhere we kept a thin gold foil. So this is the thin gold foil. Now behind this alpha gold foil, he placed a screen to identify the direction of particles which are passing through the gold foil. Gold foil means it is a thin sheet of gold metal. Okay? Now this screen is made up of zinc sulfide. Many times in competitive exams they ask in Rutherford's experiment the fluorescent screen is made up of which material? The material is made up of zinc sulfide. This is known as zinc sulfide screen. Okay? So when these alpha particles, when he passed, and these alpha rays are passed this gold foil, he observed 3 types of rays from the experiment. Okay? Because whatever the rays are passed, these will strike this screen. So based on this observation, he given the structure of atom. So how, before discussing about the postulates of Rutherford, first let us discuss what type of rays he observed in the experiment. Once if you understand the rays, in what type of rays he observed, then automatically you can conclude why he observed those type of rays. Okay? Let us see what observation he have done. Now coming to the observation done by Rutherford in his experiment. Now, if you observe there, let it be this is the atom. This is atom. Let it be. Now, he observed mainly 3 types of rays. So these are one type of rays. Okay? So what we observe from the diagram, these rays are simply passing through the atom. So these are first type of rays. Okay? Let us write what he observed. Okay, I told you three types of rays he observed. Now coming to the first type of rays. So most of the rays, so whatever the rays he passed to the gold foil, most of the rays were passed without any deviation. Deviation in the sense, change in the direction. Most of the rays, most of the alpha rays were passed simply through the atom without changing their direction. So without any deviation, they simply pass through the atom. That is the first type of rays he observed in the experiment. Now, coming to the second type of rays. Here, we know nowadays at the center of the atom there will be nucleus. Because of that, some of the rays were deflected with some angle. Okay? The second type of rays he observed is some of the alpha rays were deflected. Deflected means they changed their direction. See, actually the remaining rays are simply passing through the atom, but some of the rays were, when they come here, they change the direction. Okay? Why they changed, what he concluded, we will discuss further. Now first let us observe the third type of rays, a very few number of rays. Actually this is the direction. Very few number of rays were bounced back in the same direction. Bounced back means when the ray is passed through the foil, when it strikes the foil, it came back in the same direction without any deviation. Such type of rays are very few rays. Okay? Very few rays. Very few in the sense, just one out of 20,000 rays. Okay? So that much, very few rays were bounced back in the same direction. In whatever the direction he passed the ray, some of the rays came back in the same direction. Okay? So those are the three types of rays he observed from the experiment. One is most of the rays were passed through the foil. Some of the rays were deflected with some angle. Very few rays, 1 out of 20,000, were bounced back in the same direction. Okay? So these are the three observations made by Rutherford from his experiment. Now, based on the experiment, he explained about the structure of the atom. Now let us see what conclusions he made from the experiment. Okay? Now, let us discuss about the conclusions made by Rutherford from his experiment. Coming to the first one. What is the first type of rays he observed? most of the rays were passed through bolt foil. So from that he concluded that most of the space in the atom, most of the space in the atom is empty. Okay. So out of the atom inside, most of the space in the atom is empty. That is why all the rays were simply passed without any deviations. Okay. Now coming to the second conclusion is from second type of rays. What is the second type of rays? Some of the rays were deflected. Okay. So first we need to know why they are deflected. Generally we know that same charges repel each other, opposite charges attract each other. We know that. Okay. What type of rays he passed? Alpha rays he passed. What is the charge of alpha particle? As we know, the charge of the alpha particle is positive, because in the starting of the class we discussed it. So here if you observe there, we know this is the atom. Now from the second type of rays he concluded that at the center of the atom, all the positive charge of the atom is located. Means the protons are present inside the nucleus. The center of the atom is named by Rutherford as nucleus. And the nucleus contains these protons. So charge of protons positive. Our alpha ray is also positive ray. When both are positive, same charge, repel each other. So that is why when they come nearby the nucleus, they change the direction. Okay? So from the second type of rays, he concluded mainly 2 points. One is total positive charge is located at the center of the atom, that is named as nucleus. So nucleus contains protons. Okay? As well as from the third point he concluded, given they contain neutrons also. So mainly, while you are writing in the notes, write the point as nucleus charge is positive. Why positive means? Because nucleus contains protons. Okay? So because of the same charge, particles are deviated. One more point he concluded from this is, okay, they deviated. What about their number? How many deviated? Very few particles are deviated. Okay? Now coming to the third, very few, that 1 out of 20,000 was bounced back. Why they bounced back means they cannot pass through it. Why they cannot pass through it? Because nucleus is very hard. Nucleus is very hard. And coming to the size of nucleus, the size of nucleus is very small. It is approximately given as 10 to the power minus 15 meters approximately, is very small when compared to size of the atom. Its size of the nucleus is very small compared to size of atom. Size of the atom is approximately 10 to the power minus 10 meters. Okay? So if I ask you a question, size of nucleus is how many times smaller than atomic size means? What you will say? It is 10 to the power minus 15 meters approximately. This is approximately minus 10. So size of the nucleus is 10 to the power minus 5 times smaller than atom. Or atom is 10 to the power 5 times bigger than size of the nucleus. Okay? These are the main 3 points we concluded. Most of the space in the atom is empty. When this most of the space is empty, very small space was occupied by nucleus. That is why size of the nucleus is very small. And it contains protons as well as neutrons. That is why whole mass of the atom is located at the center. That is why nucleus is very hard. That's why particles cannot pass through it. They bounce it back. Okay? So these are the main points. Got it? So now from these conclusions, now we can give the structure of atom as we know atom is a spherical one. Nucleus is at the center. The nucleus contains protons and neutrons. Then our immediate question is, what about electrons? Okay? The Rutherford given the fourth conclusion, that is, the electrons revolves around the nucleus in a circular path. Okay? I simply mention it as we know, the electrons revolves around the nucleus in circular path. Or while writing, you can note down in the notes. Electrons revolves around the nucleus. So these are the conclusions made by Rutherford. Okay? So it is everything is good. Then why we are not following Rutherford's model nowadays? That is a drawback for that one. Let us discuss about the drawback. The main drawback of Rutherford's model is he failed to explain the stability of the, okay? In the examination, they ask many times, what is the main drawback of Rutherford's model? Because it is one of the successful model. Using experiment, he explained about the structure of atom, it is very good. Then what is the drawback of the Rutherford's model? The main drawback is he failed to explain stability of atom. Okay? As we know, atoms are highly stable. We observe our surroundings. All these are made up of atoms. Because matter is full of atoms, we know they are stable in nature. But this Rutherford failed to explain how atom is stable. The main drawback is according to classical mechanics, and you will get that law in physics. Instead of that law wise, I will tell you in a simple manner. According to the law of classical mechanics, every charged body should lose or should radiate energy during motion. Okay? Generally in physics, normally we know every charged species during the motion, means when it is doing work, it has to radiate some energy. For example, let it be the position of our electron is here. Okay? It will have some energy. Like generally when we are rotating, when we are doing running in the ground, definitely when we do one round, we lose some energy. Correct or not? When the electron, we know it is also a charged species, during the motion, it will also lose some energy. When it loses some energy, because of the attractions, we know nucleus is positively charged. So when it loses some energy, automatically the nucleus attracts the electron. It will move slowly towards the nucleus. So even when it will do one more rotation, again its energy will be decreases, comes somewhat closer to the nucleus. Like that, when we do some revolutions, somewhere definitely after some time the energy of the electron may become zero, where then it will be attracted completely by the nucleus. Then atom will collapse. As it is happening in the regularly, no, we know that atoms are highly stable. Okay? Then why, how it is stable was not explained by Rutherford. Okay? So if they ask what is the drawback of Rutherford's model, means the main drawback is he failed to explain the stability of atom. Simply. Okay? How? If they ask, you know, due to law of classical mechanics, every charged body should lose energy during motion. So after every revolution, the electron will radiate some energy. So after some number of revolutions, the total energy of electron will become zero and the atom should collapse. But it is not happening. Atom is a stable one. How it is stable cannot be explained by Rutherford. Okay? So that stability was successfully explained by Niels Bohr. So we will discuss about the Bohr's model of atom in the next classes. Okay? Thank you.